Hi, this question is related to the standing waves produced in a water tank. And you know that is always produced due to the superposition of the two longitudinal waves, means sound waves, in the water tank when the sound travels through air. Anyways, in the diagram you see that initially, actually imagine that you are doing an experiment in which you have filled a whole tank of water up to this level, right? And you produced an orifice close to the surface of the tank. Imagine at this point from where the water started rushing out. Okay. So, what we observe the first loudness of the standing wave when the water reached at this level. And then we heard the next harmonic, means the next loudest sound of the standing wave when the water level reached at that point. And in this question, we have to relate the wavelength with the value of x. And the value of x is actually this distance between these two positions. So if this is x, then how is the wavelength of standing wave is related to the x? But first, I will insist you to kindly understand that how actually standing wave is produced. So this is a tuning fork which is vibrating right now. So it is propagating its energy through the air, which is acting as a medium. So this is a certain air particle. It is executing a longitudinal wave, a longitudinal vibration. So it is vibrating like this, due to which a sound will travel. If I draw the sound like a transverse wave, but sound is a longitudinal wave. So this is a one sound wave. When it reflects back from that end, that's why we always have a node at the level of water. Okay, so these two sound waves superpose with each other, they overlap with each other, and they produce the standing wave. That's how a standing wave is produced. So all the air particles, they execute SHM. Now, so here starts the important part of our video. So look at the first loudness position. As I told you that the first harmonic standing wave is produced. So why not we should produce, I mean, there should be antinode always at the opening end, because the particles can vibrate with their maximum amplitude. It is open end. So that's why we will have always an antinode. And the at the surface of the water we will always have a node, because the motion of the particles is restricted. So that's why the first harmonic should be like this, and this part will be the dotted one. Okay, so this is the first harmonic. Now, at the position of the second loudness, we have to draw the next harmonic, which is the third harmonic. Okay, so this is obviously the antinode, and then this is a node, right? But there will be another antinode because it is a next harmonic. So the wave should be, we should draw like this. I hope you understand. So we can say that because this is a distance from antinode to the node, so that must be lambda over 4, obviously. Okay. Whereas in the next, you see that this is an another antinode. So from the antinode to antinode, it's lambda by. So this is lambda by 2, and this must be lambda by 4 because it's from antinode to node. So the total distance, it should be, just simply add them. So lambda over 2 plus lambda over 4, that must be equals to 3 lambda over 4. So why not if we subtract this distance and this distance, that must be equals to x, right? Do you like this idea? So x must be equals to 3 lambda over 4 minus lambda over 4. That's why it should be equals to 2 lambda over 4, and that's why it should be lambda over 2. So what we finally conclude that x lambda is equals to 2x, and on the basis of that, the right answer should be option D.